just wanted to show you guys how you can debug a Forge test if you've never used Forge before. Basically, Forge is a really awesome Solidity unit testing framework, and in particular, it allows you to fork multiple actual blockchains and essentially simulate a full workflow of going from AVAX to ETH or whatever, all locally, all within a unit testing framework. You never have to leave Solidity. You never have to compile. Well, you have to compile the Solidity, but that's it. Really convenient stuff. But there are a couple things about it that make it a little bit tricky. And here are just a couple of ways to debug the code. So we're going to be working off of Hello Wormhole, which is what we used in the first workshop. And I just introduced a small bug into it that causes the tests to fail. And we're going to just walk through how we fix it, or how we understand what went wrong in the first place. So when you run Forge test, and this is just like a little filter so that I don't need to leave that filter. When you run Forge test, the initial output isn't all that helpful. It just says that something failed, and it says there's this custom error. So the first thing that you probably want to do is rerun it in verbose mode. And there's a couple different levels of verbosity. You just select it by appending more V's to this CLI argument. And also, normally this is really fast when you have a good internet connection, but because we don't have a great internet connection, actually forking the blockchain takes, a couple seconds. But, okay, so we didn't get any logs that were emitted. That's, okay. If we wanted to add a log, so let's say, we're in our testing code, and we want to sort of do console log debugging. We can do something like before blah, 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 kind of like that. Then this would show up in these logs here. We could also print out values, inspect things, etc. This isn't super useful in the example that I just used here. Maybe it would be more interesting to do print out the cost or something. But if we want to get sort of a stack trace of what's going on, we can add in basically increase the verbosity level, and then this prints out a trace of everything that happened in the Solidity contract, all of the, or at least all of the external function calls, and just external function calls. So on the left here, going back, now we see the log that we had, just added, and you can, just do your sort of normal log debugging. This is ordinarily really hard to do in Solidity, because if you've tried to deploy a transaction to testnet or something like that, and send a transaction to testnet, you don't really get human readable logs, which it's just really painful to have to debug without them. But then on the right, we get this whole big mess, and this shows literally everything that happened inside the test. And we see here that, that's color coded based off of, if it succeeded or failed. And we can see that this top level, test greeting function failed. A lot of success. Then hello wormholes send cross-chain greeting failed. Again, a bunch of success until we get to this, which is a little bit indecipherable. So it's some contract at this address, and then some function, but we don't actually have the function name because, Solidity is a little unfortunate, and in the compiled bytecode, it doesn't include the string. It just includes the hash of the string. And so this is sort of where a lot of people can get stuck, right? So we come down here and we see that there's a custom error. There's a couple of fields here. This should be able to tell us something. And the trick here, and this is somewhat of a trick, is you want to copy this and then search for it, like in your compiler output. This is not a wormhole thing. This is just like EVM/blockchain development is kind of painful. So what you then do is you come down here and you say, what does this error selector correspond to? It corresponds to the message.value error type. And so what does that mean? Well, you can keep looking through here, or you can then take that name, paste it here, and find in the interface that there are, 2 arguments, the message.value that was actually passed in, and what the fee should have been. So we'll come back over here, and this is in hex. Again, everything's a little bit painful, but we now know that the message.value is wrong, and that gives us enough of a clue to be able to investigate intelligently, like how we can fix it. So we come into our contract that we were just testing, and we know that it failed in send cross-chain greeting. So we look here, and we know that the wormhole relayer is the thing that failed, because we saw that. Well, I guess maybe you don't know that, but this is the contract address of the wormhole relayer, we do know this because the error selector came from the wormhole relayer, and we saw that when we were searching it over here. So we know that it's somewhere in this function something bad happened, and we know that it has to do with message.value. So for some reason this is not right. This value cost is not correct. So where are we getting this from? Well, quote cross-chain greeting. We look up here, we see, all right, so this is what we're quoting. And then what are we actually asking for? Does the quote line up with what we're actually asking for? And we can see no. I just added 10 extra gas, kind of, this is obviously a little bit of a contrived example, but this sort of illustrates how you can use Forge to debug your things locally, and it's going to be much, much, much faster than doing it on testnet and redeploying all the time. There's a lot of things you can do with Forge, as I don't think Akshay ever went through this, or I guess, did you guys see how this wormhole test base class works, or wormhole relayer test base class works? No. Okay. So this is, again, really helpful. Basically, what you do is there's these 2 functions, setup source and setup target, that run. If you're familiar with unit testing in Jest or whatever the Java one is, or basically most unit testing suites, these functions run before your tests, and then these are the actual tests that run. You could have multiple of these. And setup source, this runs on the source fork. So you have 2 forks. You have the source chain and the target chain. And you can switch between them. It's sort of handled for you by the space class. But you will deploy your own contract here. In this case, Hello Wormhole wants the address of the relayer, or the wormhole relayer contract. So you do whatever sort of setup you need to do, and then you write your actual tests. And this starts off on the source chain. So the fork begins on the source chain, you do some stuff, blah, 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 blah. Once you've actually requested a delivery or done something, so here we're invoking our send cross-chain greeting function. And then after that, we basically call for form delivery, and this simulates the process of the wormhole guardian network. It simulates the process of the off-chain relayer, kind of all of that jazz, and it sort of manages things with the forks in order to sort of simulate that. Then after that's done, we can move over to the target fork and assert that the state that we expected to happen, assert that what we expected to happen did happen. and you can build up, unit tests like this. And again, would very, very highly recommend unit testing as opposed to like testnet testing. It's just going to be a lot faster for you. And even if the actual running of the tests and sort of the happy path isn't a lot faster, which I think it is, it's going, if you hit a problem, you're going to actually be able to get meaningful information out of it, versus the alternative would be, let's just take, this one works. So this is an internal logs, but let's say you sent this transaction on testnet. This is all of the information that you would be able to get off of like an ether scan, or in this case, it's the avalanche scan, but same idea. You'd be able to get this, but it's much, much less helpful. So yeah, pretty simple. We just look up Forge. It's very helpful.